Hello, my name is Jennifer Healey, and I'm here to present our paper on challenges in recognizing spontaneous and intentionally expressed reactions to positive and negative images. I'll go through the motivation, our initial hypothesis, the experiment, and our results. The initial motivation was the idea that humans could one day talk to computers and have computers respond the way a human would. And part of this is having computers recognize when a conversation is going well or poorly. For example, if a computer were to make a recommendation and it went well, the computer might recognize that you were happy. Otherwise, it might recognize that you were unhappy with the suggestion. However, most currently available off-the-shelf software recognizes the Ekman-6 emotions. To get our face recognizer to recognize my emotions, I had to really overact it. It took me a lot of practice, in particular to get the disgust face to be recognized. The happy face needed to be clear and exaggerated, and the disgust face also needed to be exaggerated. What I would really like is if there were a more robust way of recognizing positive and negative reactions, because I don't believe that anyone is going to be making these iconic faces naturally with any frequency. But really what we want is more of a positive, negative ometer. So just understanding whether things are going well or poorly and the degree to which that is happening. But what we have are the Ekman-6, which are universally recognized facial expressions, but they're not necessarily the most common facial expressions, nor do they smoothly span the space of emotion. In fact, only one of them is even positive, which is happiness. What I wanted to do is leverage all the work and data sets that are labeled with the Ekman-6 and be able to map those onto the negative positive axis. I wanted to leverage the facial action coding system to find which action units might be sort of the key leading indicators of positivity or negativity. Each of the Ekman-6 are encoded with these facial action coding units, and that's how you can recognize signature looks like fear through all of these action units. I chose to look at happiness, sadness, anger, and fear as representative emotions for the spectrum of positivity to negativity, and chose action units 6 and 12 as representing a positive signal, and 1, 2, 4, 5 as representing a potentially negative signal. And I wanted to try this out to see how this would work on our experiment. Essentially, the negative signals all have to do with eyebrow action, and the positive signals I chose all have to do with cheek action and cheek and lip action. Our experiment was to just have people look at positive and negative images that we chose from the OASIS image data set, and we chose the highest arousal positive and negative images. And then we randomized the images and had people look at them in 2 sessions. The first one, we told them just to react naturally, and the second one, we said intentionally express what you're feeling, as if the computer could understand your emotions. This is an example of what the actual experiment was. First, you saw a white slide, then an image is exposed for 5 seconds, then another white slide separates the images. Here we saw a positive, a negative. This is the white slide. And now you'll see another positive image. This is what the subjects were asked to look at during the experiment, and this is exactly the pace at which the experiment was run. Our hypothesis was that positive and negative reactions could be distinguished by looking at differences in these action units. We expected to see a high activation energy in AU6 and 12 for positive images, and high activation in 1, 2, 4, and 5 for negative images. We also expected that intentionally expressed emotions would be more intense than spontaneous emotion. So we had people sit down and we used open face to look at their reactions as they watched these images. This is an example of a participant taking part in the experiment. They are asked to watch the images in an office. The video was post-processed using OpenFace to detect the face outline and the expressions. It seems to work well even on participants wearing eyeglasses. You'll see that this participant will often vocalize when intentionally expressing their emotions. Right now, they just said, wow. This is something that Ekman warned about, that you don't want, that this is a confound to facial expression analysis. There you saw some eyebrow action. Here you're seeing a sneer, which could be confused with a smile. But these are the intentionally expressed reactions. This is the strongest type of reaction that we got. Again, a vocalization. But all participants were very attentive to the material. And what we found was that for some participants, our hypothesis held. We saw far more energy in the positive action units for positive images, and far more energy in the negative action units for other images. But for other participants, their reactions to positive and negative images, this is a positive image, but it has a negative reaction, and this is a negative image with a negative reaction. So in other words, for some participants, they did not react the way we were expecting at all. We summed this up by looking across images. These are the 20 images that were shown. And what I'm showing are congruent reactions. In other words, if the image, like image 1, is positive, I'm showing the number of people who we correctly predicted as positive by looking at the ratio of AU6 and 12 averaged to the ratio of the -4 averaged. And so what we found is, first of all, this would be chance. And we didn't really do much better than chance at all. In fact, we're biased towards negative, so we do slightly worse than chance. And then I want to break it down by particular images. You can see that for image 4, we did get a pretty strong reaction. This is a building that's on fire. So we actually did recognize that as negative. We got strong negative reactions in both the natural and expressed categories. Another image that did well is image 6, a child with a gun. And another image that got a strong reaction is image 17, which is a war image of dead bodies. Images that did not do well tended to be the more positive images. For example, image 15 was not well recognized at all. We had some complaints about this looking too artificial, and one person said it looked like the rainbow had a shadow and they didn't buy it. So we had some negative reactions to image 15. Image 20 also did not do well in terms of generating a positive response, potentially because some people thought it looked like a war image, even though it's supposed to be fireworks. And image 5, an image of a lake, had a varied reaction. We saw this with a lot of people, which is when they naturally reacted to positive images, they didn't react very strongly, but when they're asked to express it, this is one of our strongest results. When they're asked to express it, we see far more energy in these two positive AU indicators, these happiness indicators, when they're asked to express it. So we see here a big difference between spontaneous responses and intentional responses for the lake image. Here's some of the problems we encountered is that for some people, things like this image of garbage, which is supposed to be incredibly negative, they kind of showed contempt or they smirked. And this might be because the other images are so violent that this seemed like nothing. You're like, oh, this is a negative image? I'm not going to react that strongly. And another interesting reaction we had was sort of a more wistful reaction to a sunset. And the person's like actually going, oh, and oh, you know, that's nice. But they don't smile. Reactions to the dead bodies included people turning their head away and shaking their head, which is a little bit difficult, but they don't necessarily frown or do a lot of eyebrow motions. And another thing that people do is they vocalize, which is another thing Ekman warns about, is watch out for vocalizations because it changes. And this person in particular also didn't have a lot of eyebrow action. So people didn't necessarily react the way we were expecting them to. For the AU intensity, this is the overall participants. We did get the result we were looking for, which is, or we're expecting, which is that in the intentional case, across all action units, there is higher intensity in the intentional case. We were expecting it to actually be bigger, such as for participant 1, where in the intentional case, we're seeing far stronger intensities in the action units. However, in some participants, like participant 4, and this is something we found overall, there was a strong difference, a very strong difference between the spontaneous and the intentional in the positive images, but not as much in the negative images. In fact, participant 4 didn't register either of the positive AUs at all for any of the positive images in the spontaneous case. Participant 6, on the other hand, and this is scaled, so this only goes to 1.8, whereas this goes to 3, so this is less intensity overall. They have a similar spontaneous and intentional profile, and again, AU6 being almost non-existent in the spontaneous case. But here we see actually in AU5, there's more intensity in the spontaneous than the intentional case, and that's the only time that that happened across any action unit. So in conclusion, we found that we could not easily differentiate positive and negative emotions based on looking at this ratio of AUs, that we were highly negatively biased, and this had a lot to do with the lack of strong positive responses. And we did find that intentionally expressed emotions had more AU intensity, but we actually found this was far more true for the positive emotions than the negative emotions. I'm very interested in improving this result, and I got a lot of great comments and feedback from the reviewers on new things to try, so we'll be looking into that actively. I don't have any new breakthrough results yet, but I am hoping to improve these numbers. And this is an active area of research for me, so if you are also interested in this area and would like to collaborate, please feel free to reach out to me at this email address. Thank you very much, and hopefully now I'll be taking questions live.